Tasha, but it's too hard. Can you help me?
Seriously? This is quite easy. Let me show you. Let's go.
Where am I?
Hi, Tasneem.
Oh, hi, Africa. Where are you? Why am I here alone?
You are in my imagination now.
So this is your imaginary badminton court. Oh, I see. Look, there's two people playing badminton. Hey, look, the guy keeps on losing. It's so funny.
Oh my god, why do I keep losing? Stupid shuttlecock!
Ha ha ha, poor guy. He just wanted to win.
Enough with that, Tasneem. Let's analyze how he hit the shuttlecock again. Let's say the guy is standing 6 meters from the wall. He served the shuttlecock, which was 1 meter from the ground, with a force of 150 Newton. The ball traveled with an initial velocity of 30 meters per second at an angle of 50 degrees. Note that the height of the wall is 5 meters. Do you think the ball will land on top of the wall, or it will continue its motion past the wall and land somewhere in the field? Let's find out using the concept of projectile motion.
In order to apply the concept of projectile motion, we need to break down the motion of the shuttlecock into its x component and y component. The initial velocity of the shuttlecock along the x-axis can be calculated using the formula 30 times cos 50. The velocity in the x direction remains constant as external forces are neglected. So, the value of the initial and final velocity is 19.28 meter per second. Since gravity acts vertically and not horizontally, the acceleration of the x component is equal to 0. For the y component, the initial velocity of the shuttlecock can be calculated using the formula 30 times sin 50, which yields a velocity of 22.98 meter per second. The final velocity is unknown, while the acceleration is equal to g, which is negative 9.81 meter per second squared. When the shuttlecock reaches its highest point, the velocity of the y component is equal to 0, while the acceleration remains constant. With this information, we can calculate the time taken by the shuttlecock to travel by half of the distance. From the formula, the value of t is equal to 2.34 seconds. Now, we can calculate the total vertical displacement of the shuttlecock. By plotting in the data, we get the total vertical displacement is 26.92 meter. Since the shuttlecock was served 1 meter from the ground, the maximum height that the shuttlecock can reach from the ground is 27.92 meter. So, if the guy is standing 6 meters from the wall, what is the height of the shuttlecock at the time when it reaches the wall horizontally? Will it hit the wall, land on top of the wall, or clear the wall? By plotting the data obtained into the formula, the value of t can be calculated, which is 0.311 second. So, when t is equals to 0.311, the total displacement of the shuttlecock vertically from the ground is 6.67 meter. Since the shuttlecock is served 1 meter from the ground, the vertical displacement is 7.67 meter. Hence, the shuttlecock will clear the wall and land beyond it. Thank you.